Let's look at an example. Now this is a standard vector question. It's just going to ask us for the answer in polar form. So the question says a bushwalker walks 16 kilometers in the direction of bearing 050 degrees, then walks 12 kilometers in the direction of bearing 210 degrees. Determine the resulting position of the hiker, giving magnitude and direction. Now this is important, from the starting point. So you know where your bearing is going from and to. And then finally, state the resultant vector in polar form. So let's draw a diagram. In my head, I'm thinking bearing of 50, that's up, northeast kind of direction. Then a bearing of 210, that's over 180 degrees, so coming down, so that's southwestish. I need to know where to start my diagram. To be able to fit it on my page, I'm going to start down here. So try and visualize what's happening before you start drawing. 50 degrees is just over 45. Again, it doesn't have to be perfect, but you want a good representation. Now the other thing I'm going to do is, you don't need a 2-scale drawing, but when doing these questions, to get an idea of where you're at, it helps to get those positions relatively correct. Okay, so this is 16 kilometers. And now 210 degrees for 12 kilometers. Now I've kind of cheated and used a ruler. So I'll explain what I mean by that. I want to know whether this end position is to the south of my starting point or to the north of my starting point. That will help me. So what I've done when I've drawn my picture is I've made that 4 centimeters and I've made this one 3 centimeters. So I've got the scale right. Okay, it just helps me to know my end position. Now with my angles, I haven't used a protractor. They're about right, they're not exact. It's mainly the length of the lines to know whether my finish point is to the north or south of my start. So I know when I find my answers, do they seem right? Okay, that's important. Now in regards to vectors, I should be putting arrows on my lines to show direction. So my resultant is this vector here with that arrow. So this is my resultant. In regards to the angle, it wants the resultant vector in polar form, and it wants the direction from the starting point. So in regards to that, I'm going to find that angle there and answer with a negative. Okay, if you weren't doing that, your other option is you start from the positive x and you'd have to go all the way around. So there are your 2 options. So let's think about how we're going to answer this. I'm going to start with the resultant because that's a nice easy one. So magnitude, which is my resultant, now you can see I have this side, I have this side, and I want the other side. Do I have the angle in the middle? Because I'm going to need that to be able to use my cosine rule. So to find that, I know this angle here, which is alternate to the 50 degrees. So I know all of that is 50. I know this little angle, and I should have really drawn my picture a bit bigger. So this angle in there is 210 minus 180, which is 30 degrees. So that means my star angle, the one I want, is going to be 50 minus 30, which is 20 degrees. Now it might help you to draw the triangle without all the bits of information that you've put on it, so you can see what's happening a little bit clearer. Especially, I know a lot of students draw these tiny triangles. Try and make it big so you can see what's happening. Okay, so that's my triangle. There's my 20 degrees that I found. I've got my resultant. So you should be able to see, looking at that, that you're going to have to use a cosine rule. Now, another thing that might help you is to label your triangle so it matches your cosine rule. So a squared equals b squared plus c squared minus 2bc cos of a. Plug in your information. 16 squared plus 12 squared minus 2 times 16 times 12 times cos of 20. Go to your calculator. You get approximately 39.16. So a is approximately the square root of that, which is approximately 6.26 kilometers. Now going back to my original diagram for polar form, now going back to my original diagram, to be able to get that theta, I need this entire angle here. We'll label that alpha. But if you come back to your big triangle, that's that angle there. So angle C. So for my angle, you can see that we have that. I just worked out this 6.26 kilometers. So I have the opposites there. So I'm going to use my sine rule. So sine C over C equals sine of A over A. Plug in my information. Sine C over 12 is going to be sine 20 over 6.26, and then multiply both sides by 12. Now use the answer in your calculator for the A, that's 6.26. So when you go to your calculator, go sine of 20 divided by answer, then times it by 12. So you're not using the approximate answer, you're using the exact answer. So that's 0.66. So C is approximately inverse sine of 0.66. Again, use your answer and you get 40.99 degrees approximately. Now I want the theta. Go back to my diagram. This little angle in here has to be 90 minus 50 because of the right angle, which is 40 degrees. So that means theta is my 40.99 minus 40, which is approximately 0.99 degrees. So tiny. Now if we look at our diagram, because we try to get it relatively accurate, that does make sense. Okay, so that small angle makes sense. When we write our resultant vector, we have to remember that this is going to be the negative because we're going down in a clockwise direction. Now I've run out of room. I should write it below, but I'm going to write therefore resultant vector is approximately, now my magnitude was 6.26 and my angle is negative 0.99 degrees. Okay, it also helps make that answer stand out if you aren't working down your page like I have. I ran out of room. You should always work down your page. But make that answer stand out.